Hello, my name is Vince Tancredi, and I did my assignment on Buckminster Fuller. Buckminster Fuller was an American author, inventor, and architect who lived from 1895 to 1983. Fuller was a pioneer in thinking globally, and he explored principles of energy and material efficiency in the fields of architecture, engineering, and design. He is most well known for his design of the geodesic dome, which have been used as parts of military radar systems, civic buildings, environmental protest camps, and exhibition attractions. It was Fuller who was greatly responsible for popularizing the term synergy. Here are three projects by Buckminster Fuller. First is the Dymaxion car. Three prototypes were built in 1933, and one is now on display in the National Automobile Museum in Reno, Nevada. The bodywork was aerodynamically designed for increased fuel efficiency, speed, and lightweight. Second is the Dymaxion house. The project was finished in 1930, and a prototype is currently held at the Henry Ford Museum in Dearborn, Michigan. This was designed to address shortcomings in traditional home building techniques. And finally is the Fly's Eye Dome, which was designed in 1965. Fuller designed the dome as his idea of an affordable portable home of the future. A 50-foot prototype acquired by Crystal Bridges Museum of American Art in Bentonville, Arkansas, will be installed this year in 2017. My focus project was the Montreal Biosphere. The Biosphere is Buckminster Fuller's most notable project. The dome was originally an enclosed structure of steel covered with 1,900 acrylic cells surrounding an interior exhibition space. The dome was constructed in Montreal, Quebec, Canada, in the year 1967 for the World Fair Expo 67. The dome itself is 250 feet in diameter and 200 feet high. The space is currently used as a museum dedicated to the environment. Fuller utilized his many years of experience constructing domes across the U.S. to design this project. The Biosphere epitomizes Fuller's idealization of the promise of technology. The lattice pattern used for the steelwork was efficient and mass-produced, cutting down on waste. He also implemented design elements of the human body in his project. In my opinion, Buckminster Fuller's Biosphere is a successful work, accomplishing Fuller's goal and further introducing the world to his sustainable, efficient designs. The innovation seen in this structure captivated onlookers in the 1960s and continues to do so to this very day. The technology used to design the Montreal Biosphere was simplistic yet ahead of its time. The geometry used to connect the structure is stunning in its own right. It is clear from the way Fuller used small, uniform materials for construction and simple connection points that he took future upgrades into account. Sustainability was a high priority for Buckminster Fuller when he originally thought up his design for the geodesic dome. In the time of the Great Depression, materials needed to be conserved and made at for a low cost. Astonishingly, Fuller took his idea of conservation and was able to build something remarkable. The Biosphere was designed to conserve energy as well as materials at a low cost. Even after a disastrous fire in 1976, the structure still stands as a pinnacle of sustainability. To this day, the structure emanates an aura of creativity and inspires curiosity in those who see it. As an architectural achievement, the Biosphere epitomizes Fuller's idealization of the promise of technology. Through holistic consideration, systemization, and mass production, he saw this project as an example of how architects could innovate to create new, efficient machines for the good of mankind. He also intuitively tied his architecture to humankind itself. The original purpose of the Biosphere was to intrigue the world and bring individuals together for the World Expo. To stimulate this human interaction, Fuller designed the Biosphere's sun shading system to imitate the biological process of human pores, further expanding the connection between humans and their creations.